Hello friends, today let's solve two questions about the lowest common ancestor. The first is on the binary tree, the second one is on binary search tree. We'll see the difference between these two questions. Let's first see what is LCA. LCA, lowest common ancestor. The LCA is defined between two nodes P and Q as the lowest node in T. It has P and Q as a descendant. Let's see some examples. The first one, if the root, this is the root tree, the P is 5, Q is 1. We can see in the graph that the LCA of these two nodes is this 3, so we just return 3. Let's see another example. In this example, the P is 5, the Q is 4. So this is interesting that the LCA of these two nodes is one of its nodes is just 5. So we just return 5. In this question, we also have some constraints. Let's see. It says that all node values are unique and P not equal to Q and PQ will exist in the tree. So let's think how to solve this question. From the second example, we can see that sometimes the LCA of the two nodes will be one of these nodes, and the condition is that the value is equal to the root value, right? In this subtree, the root value is 5, and one of its node value equal to 5, so we just return this root. Usually, for a binary tree question, we will use recursion. So usually we'll have a base case and a recursive case. So for the base case, you already think about it, is that once the root equal to none, we should always check it. If equal to none, or the root dot value equal to one of the node's value, so P dot value or root dot value equal to Q dot value, we just return the root. So this is the base case. So how about the recursive case? One situation is that, for example, if we need to find the LCA of this 5 and 1, we know it's the root node. For this whole binary tree, if we want to find the LCA of this 5 and 4, we know this part should return a none. This part will return a 5. So that means we also need to get the tree recursive to get the tree node of the left and the tree node of the right. So we will call this function, but I change this root to root dot left, and for the right we change it to root dot right. So now we have two nodes. We compare its value. If all of them are not equal to none, that means we should return the center node or root node. If this one, for example, in this situation, the left not equal to none but right equal to none, we just return left. So if left equal to none, right not equal to none, we return right. Okay, this is this question. Let's see for the BST. Basically, it's the same. For the base case, we just check whether equal to none, and or the root dot val equal to P dot val, or root dot val equal to Q dot val. If yes, just return root. The recursive case is simpler because in BST, all the left node's value less than the root value and all the right value greater than the root value. So if all the p and q, this value less than root, if both of them less than root, we should go left. So if p dot val is less than root dot val, and q dot val less than root dot val, we go to left. So we call this function and change it to root dot left. If all of these two values greater than root dot val, so we go right. Otherwise, we just return the root. So basically the same. About the time complexity should be big O(n), because the worst case is just looks like a linked list. So it's n is the number of nodes in this tree. Okay, now let's write the code so you can understand this problem better. Okay. First, we do a base case check if root equal to none, or root dot val equal to p dot val, or root dot val equal to q dot val. We return root. Otherwise, get left equal to lowest common ancestor, root dot left pq. Tree node right equal to lowest common ancestor, root dot right pq. Check if left not equal to none and q not equal to none. Just return root. Oh, sorry, not q. It's right. Return root. Otherwise, return a non-root. So left not equal to none. Return left. Otherwise, return right. So this is the binary tree case. Okay, so let's see this binary search tree. The base case is the same if it equal to none, or root dot val equal to p dot val, or root dot val equal to q dot val. Just return the root. Otherwise, if p dot val less than root dot val and q dot val less than root dot val, we return the left lowest common ancestor, the root. Go left p and q. If p dot val greater than root dot val and q dot val greater than root dot val, we just return lowest common ancestor, root dot right pq. Otherwise, return root. Okay, thank you for watching. See you next time.